Hey there, Mr. Sutton here, bringing you the Algebra 2 3-2 Part 1 homework solutions on complex numbers. In this one, we're going to focus on simplifying square roots that have negatives inside and also solving quadratic equations that have complex roots. On this problem, they just want the square root of this number. Since there is a negative inside here, we're going to take out an I. That's the square root of -1 that we're essentially factoring out of there. So we'll rewrite this as I radical positive 25. Square root of 25 is 5, so this is just 5i. On this one, since I have a negative inside my square root, I'm going to take that out as an I. It's going to join the -5 that's already out there, so -5i square root of 9. Square root of 9 is 3. 3 times -5i is going to be -15i, and there's nothing more we can do on this one. For this problem, I'm trying to find the square root of this number, or at least simplify the radical. So let's take out an I to begin with. That'll give us -4i radical 32. And then we just need to split up that 32. 32, we can break it up into a perfect square of 16 times 2. Square root of 16 is 4. 4 times -4i is -16i. And then we have that radical 2 along for the ride. For this problem, we're trying to solve this equation for all complex roots. Since I've got this x squared and just a constant, I think I'll be able to just solve this by square rooting. Let me subtract the 4 over to the other side to get the x squared alone. And then we'll take the square root of both sides. That gives me x equals plus or minus square root of -4. And since I have a negative inside the radical, let me take out an I. So we have plus or minus I root 4. 4 square root is just 2, so this is just plus or minus 2i. To solve this equation for the complex roots, let me see if I can isolate this x squared. I'll start by subtracting 6 from both sides, so that'll be -40 over on the right side. And then if I divide by 2, we've got -20 over there. And now I'm just going to take the square root of each side. So we'll have x equals plus or minus square root of -20. Since I have a negative inside the square root, I need to take that out as an I, so plus or minus I radical 20. And then 20 is not fully simplified because I can break it up into a perfect square of 4 times 5, both inside square roots. Square root of 4 is 2, so this is going to be plus or minus 2i radical 5. On this problem, they want the complex zeros of this function, so let's start by setting it equal to 0. And then if I can just isolate this x squared and square root things, I should be good. So let's subtract the 6 and divide by 3. We have x squared equals -2. If I square root both sides, I have x equals plus or minus square root of -2. And then as a last step, since I have a negative inside there, let me take that out as an I. So plus or minus I radical 2 would be our final set of answers. On this one, we're trying to find the complex zeros of this p of x function. We'll start by setting this equal to 0. And now if I just isolate x squared and square root it, I should be good. So if I subtract 98 and then take the square root of both sides, we have a plus or minus square root of -98. I have a negative inside, so I can definitely take an I out of all that. And then I know that 98 is 49 times 2, and 49 is a perfect square, so I'm going to split it up that way. Square root of 49 is 7, so we have plus or minus 7i radical 2. For this first of two problems in the honors part of this problem set, we're trying to find x and y values that make this equation true. So basic idea is we're just going to set the real terms equal and the imaginary terms equal, and that'll give us two equations we can use to solve for x and y. So for the real terms, I have 3x, and that has to equal 27 for these two things to be equivalent. Dividing by 3, we get x equals 9. And then I can also write 6i equals yi. And dividing by I gives us 6 equals y, or y equals 6. For this problem, I'm just going to take the real terms and set them equal, and the imaginary terms and set them equal. That'll give me my x and y values that make this equation true. So I can write 9x equals -36. Dividing by 9 gives me an x value of -4. And for the imaginaries, we have negative 18i equals 6yi. If I divide by 6 and I, that gives me y equals negative 3.